Welcome to part 2 of 6.2. We're looking at ellipses, and it's time to see what's really going on with an ellipse. We see how it's not too difficult to graph them. We just find the a and our b, and the x's with the x and y's with the y, taking the square roots, and we know that it's equal to 1. But where does this set of points come from? With the parabola was all of the points that was the same distance from a focus and a line, called the directrix. Well, here's what's happening in an ellipse. In an ellipse, it has two focuses, and the plural of focus is actually foci, F-O-C-I. It has two foci, and they're both on the major axis, whichever axis is longer. And the idea is if you take a line up to the ellipse and a line from the other one, where this line plus this line all add up to the same number. So if we went this way and this way, this line plus this line equals this line plus this line. Or if we went down and up, this line plus this line, all of the lines add up to the same number, a constant. And so even this endpoint over here is this distance plus this distance. That's going to be the same as all of these other distances when you add them together. So that foci, that's what the foci is, and the letter we give the foci is C. And there's a great formula for finding the value of the foci. Remember, it's on the major axis, so this ellipse over here would have foci, I don't know, about there and there, like that. So that distance from here to here would always add up to the same thing. So here's the equation. It's C is equal to the square root of a squared minus b squared. And that kind of looks like the Pythagorean theorem. It's not the Pythagorean theorem. It's loosely related. But that's the formula. Now this has to be positive, okay, inside the square root. So whichever number is bigger, that's what you put in for a. And so this square root always has to be positive. So let's do it. Let's say we've got this ellipse right here. And let's plot it. So let's give all of the different things that the question is asking for. So the first thing I'm going to do is graph it. We see that the center is both of these. First off, we're already equal to 1, so we know we're ready to go. There's a plus here, and x is squared, y is squared, so we know it's an ellipse. So the center is going to be the point -3, -5, because you just flip the signs as you're used to. So -3, -5 right there. There's our center. Let's see, it looks like our major axis is going to be up and down because the larger number is with y. So the square root of that is up 4, down 4. Okay, and those are called the vertices. So the major axis are the vertices. And those 2 points are going to be 1, 2, 3. -3, -1, and -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3, -9. Okay, so those are our vertices, the two y parts, because that's the major axis, -3, -9. This also tells us our foci will also be on this up and down line. Let's find the minor axis points. So the minor axis endpoints are going to be, it's 3 in each direction from the center. So 1, 2, 3, 1, 2, 3. So that's the point 1, 2, 3, 4, 5. So 0, -5. And 1, 2, 3, 4, 5, 6, and 5. So -6, -5. So we found the center, the vertices, the endpoints of the minor axis. Let's go ahead and draw this in. Let's calculate the domain and the range. So remember, when we're asking for domain, it's where is the graph located in regards to x. And the graph is only in between our two minor endpoints. So it's only between -6 and 0. So the domain would be square bracket -6 to 0 square bracket, because we only have graph in between these 2 points from the left and right. Similarly, our range is going to be limited. We're only going from -1, it looks like, down to -9. So the range is going to be closed brackets, -9 up to -1 closed bracket. So the ellipse is very contained, kind of like a circle. Okay, there's the domain and the range. So we got domain, range, center, vertices, endpoints. So the last thing we need to do is find the foci, and we do that by finding this c value, okay, c for foci. So let's do it. We know that in this case, a squared, remember, is 16. B squared is 9. So a is our larger number, so a equals 4. B equals 3. A squared is 16. B squared is 9. So this is going to be c equals the square root of a squared minus b squared, or c equals the square root of 16 minus 9, which equals the square root of 7. So c is the square root of 7, and here's how it works. The square root of 7 is how far away from the center the foci is located. Okay, so the square root of 7, this is our major axis, so our foci are going to be square root of 7 up from here, and the square root of 7 down from here. So as a reminder, our center point was -3, -5, and so our foci are going to be, they're going to all be on the same x value, so they're going to be -3. And remember, this value was -5 for the y, so it's -5 plus √7 will be the first foci, and -3 comma, again, -5 minus √7. And if you plug those into your calculator, you can get the exact, or an approximation with the decimal. So √7 is a little bit less than 3, so it'll be around there, and about there are the foci. Okay, so again, I just took they're all on the same x value, so they're all -3 with the center. You take the center point, which is -5, add c, subtract c. There are your two focuses, or foci. Let's do this one. We'll do this one a little quicker. So here, our center is going to be 0, 0, because we have no x minus or y minus, so we're on the origin. Take the square root of that is going to be 10, so we're left and right 10. We're up and down 1, because the square root of 1 is 1, and this is y squared over 1. So here's your ellipse. Kind of flat. All right, so the vertices, which are on the major axis, those are going to be 10, 0, and -10, 0 in this case. The minor axis points, endpoints, are going to be 0 for x, 1 for y, and 0 for x, -1 for y. We got our center, we got our vertices, domain and range. Domain is going to be from -10 to 10 with closed brackets, because we're going from -10 to 10, and the range is going to be from -1 to 1, also with closed brackets, because that's how far up and down we go. So now we just need to find the foci, and again, c is equal to the square root of a squared minus b squared, where a is the larger of the two numbers, so that the square root is positive. So the square root of 100, or actually no, it's a squared, so we do c equals the square root of 100 minus 1, because it's a squared and b squared, or in other words, just the square root of 99. And we can simplify the square root of 99 because I can pull off a 9. So that's the square root of 9, square root of 11, which is 3 root 11. So the c distance is equal to 3 times the square root of 11. So we need to add and subtract that to the vertex like we did before, to the center I mean. We need to add and subtract that from the center, but because it's at 0, that just means that it's going to be about here and here. And that's where it's going to be. So our foci, we know that they're going to be on the x-axis, so that means the y parts are going to be 0. And in fact, it's just going to be this 3 root 11. 3 root 11 comma 0 and -3 root 11 comma 0. So there's the two foci. Over 3 root 11, over 3 root 11. And what is that equal to, actually? Take the square root of 11 times 3. So approximately 9. Oh, wow, 9.9. So they're actually going to be really close, closer than I expected. That's a better approximation of where the foci are going to be, really close to the ends of the ellipse. Possibly because it's a really narrow ellipse, they get closer to the edges. Okay, remember if this had been at a separate point, like up here, we would have just had to add and subtract that C distance from wherever the center was. Okay, that's how you graph the foci and all of the elements of an ellipse. You need to remember this equation for an ellipse. Remember that the square root is positive, and hopefully all of this makes sense. We have, I think, a few more examples to go, but we're almost done. I will see you in part 3. See you there.